for making it, gentlemen. Many could not make it today, as we see around us. Some were sick. Some are just not here. It's all right. So a little warm up question. Just keep practicing these things. And like I said, we're going to do these every day that we have left. We have 4 days left after today. Absolute madness. Remember that Monday we are not meeting. I will record something for you, so you do not have to be here in person, which will be easy for some of us. Hello, Kevin is here. Look at that.
The one and only.
Indeed, indeed. So warming up. So what I want you to do is take a minute and look at each of these series I'm about to give you and tell me what kind of series it is. Now we only know 2 kinds. Well, we know 3 kinds. It won't be a telescoping. So first one, what are the answers? The possibilities are geometric. And then the other kind I introduced at the end, but I didn't name, but it's important that we start naming it and start being able to identify it. So a geometric series looks like this, has the common ratio. Remember, common ratio. And a p-series looks like this. Now these starting indices, these are irrelevant. Where it starts does not matter. What matters is the rhythm of the terms. That's what we're looking for. So p-series, again, this is a series that looks like, so this is 1 over, put that there just to be keeping the rhythm. A series that looks like this. So there's some constant power that the numbers, the indices are being raised to. Where, as opposed to a geometric series where we've got a plus ar squared plus ar cubed. Notice that here the power is changing. And how do we identify that? We're looking for a common ratio between all the terms. So we have this common ratio r. Down here, we have the denominator being raised to a consistent power. So let's just take a look at a few. And just take a moment to, and then maybe the answer could be none. Neither. So first one, let's see here. So we're going to have, better settle down. Here. Okay. And you could assume that whatever rhythm you maybe observe at the beginning, well, we'll do one more to make sure it's pretty clear. If you think it's a geometric series, what's the R? If you think it's a P series, what's the P? If you think it's neither, you don't have to find either of those things. You just have to convince me, or first yourself, that it is neither of those things. So, no. Take a minute, do that. Doing warm up, kind of missed the intro, but you'll have to kind of figure it out from there. series, I would ask one more question, I guess, out of it. If it's geometric, does it converge? If so, to what? That would be the additional. So if it's geometric, does it converge? To what, if so? Gonna give one more minute, just to see someone working on number 4. Just wanna wrap up their thoughts. All right, cool. Kevin, what's number 1?
Is 1 over n to the cube.
Yes, so it is P series, P equals 3, absolutely. So this is 1 over 1 cubed plus 1 over 2 cubed plus 1 over 3 cubed, 1 over 4 cubed. On down the way, we see that the base is changing, the exponent is constant. So remember, constant exponent is essentially a P series. Yes, P series. So this is P series, P equals 3. Cool, Vincent, how about number 2?
I got geometric.
Nice. Can you tell me a little more?
Yeah, the ratio, I got 3 over 8.
Okay. So I'm gonna actually push back on that. It is geometric, but the top isn't changing, is it?
Maybe 1 over 8.
So 1 over 8. Yeah, so cool. Yeah, but you're right. So 1/8. Does everybody see that? Geometric, 1/8. Does that converge?
I said it converges to 0.
Yeah, and why would that be?
Because r is less than 1.
In magnitude, absolutely. And since magnitude of r is less than 1, it converges. And did you happen to get a sum?
No, I did not.
That's okay. Can somebody help me out with the sum here? What's the first term? 3 goes on top. 1 minus common ratio. So, and then we can simplify or not, but that's right. Is everybody cool with that? We feel good? PK. What do I got here, number 3?
I was thinking it's P series, but I don't know. I'm looking at it again. I feel like it's geometric.
So what would be the common ratio? I did give you the hard one. So you're
I
welcome.
think it was probably like -1 over 8, but I'm looking at the way it will progress. It doesn't look like it will work, but.
Yeah, because from
given
here to
something-
here is minus 1/8,
Yeah.
right? And so if it was geometric, the next term would have to be what?
1 over 64.
1 over 64.
Yeah.
So this is not geometric. So cool, we know that. It is not geometric, there's no common ratio. Let's just write this stuff up. Fantastic. So what about P series? Do I see any plus minus stuff going on up there? In the archetype of P series?
No.
No, right? These bases, one of these, the only way that you can't get a negative number by raising a positive number to any power. Yeah?
Mhm.
So if I see alternation, if I see this alternation, that's actually a special kind of series called an alternating series that I'll do a little lecture about that you will watch because you won't be here on Monday. You'll have a lecture to watch instead on recorded one. So this is alternating, which just means I have a series that goes plus minus, or minus plus, alternating, not a P series. And so let's actually write that up. A P series must have all positive, all terms the same sign. How do we feel about that? Alan, my friend. What's that last one? Because you were a guy I was waiting on. No. You might have noticed as soon as you set your pencil down, I started to yeah.
Well, if it's geometric, the common ratio is -8, but I'm not sure if that works because of the way the signs alternate. Because it's two negatives and then positive.
It's a little tricky here, isn't it? Yeah, so what would make it geometric? What would,
I think it would have to, that the first negative would have to be, no.
maybe, I mean, so if I made this,
But then it might,
and I have a positive 1/8.
but then it's negative, but then it's positive, yeah, okay.
Yeah, so it doesn't have a common rate, it sure feels, what did I have there? I
You
don't
had
know.
two negatives and then. yeah.
Okay, cool, thank you. So this feels geometric, but it doesn't have that common ratio. Does everybody see that? This is not geometric. Is it a P series?
It can't be for the same reason.
It can't be for the same reason, and because P series must have all terms the same sign. We don't get that plus minus. This isn't even an alternating series because I've got a really weird rhythm to it. So this is nothing that we can name. No name for this series. No name. That was a tough one too. So that we'd have to, that's a hard one to even deal with. Sound good? Cool, nice warm up. So is anybody done with the web work? That would have been impressive. Cool, that's why we're here today, in fact, isn't it? Let's get that shit knocked out. And there are some I'm waiting to be asked about, so don't hold back on questions. You know my strategy. Kellen, just so you know, I had thought about making that r equals -1/8, and then just kind of put a little wrench in the works. So good work on seeing that. You leaving?
My coworkers need me.
Oh, did you just get like the bat signal or something?
Yeah.
Cool.
The guy I was waiting on finally finished what I told him to do 2 hours ago.
All right. Yeah. Gotta love those bad students, right? Like that bastard. Taking forever. All right. You have a good one. Are you good on the web work?
Yeah.
Okay. Cool. I'll see you on.
There's a few things I didn't know how to do, but I'll look it up.
All right, and they'll probably check the video out.
Yeah.
I'll probably answer them. So I'll see you on Wednesday of next week.
All right.
And you said the bad symbol, I was thinking about like the letter K, which is projecting this kind
Yeah. Let's put it up here. Maybe he'll come back. It would have to be, I can't do it reverse, you know? We'll see if he watches the video. And my dad's Kevin, but you're gonna watch this video. So if you do, send me an email that says K. thought process? So let's, first off, what does this series look like? So this is like, this thing is all about writing out the series, either in paper or our mind. So what, I'm gonna actually recommend you do that. And then look at these and see what these look like relative to that. Just take a minute and do that. So problem one is write out those series. Very close attention to the, you kind of got the right idea. You definitely got the right idea. So write it out, write it out, write it out. Write them all out. This is, I knew you'd see it. There you go, look at that. Excellent. You're doing all right, Kellen.
I think so.
I might actually record a couple of lectures to watch over the break. We have 4 classes left. We've got a lot of shit we need to get done.
Oh, really?
Well, stuff I want to get to at least. What's that?
You have 4 classes now?
Yeah. We have next Monday. We come back. We have 1 week of class with 3 days.
And then it's fine.
So wait,
And then it's finals week.
so we are gonna have an in-person class Monday?
I'm counting
Oh,
it
you're
as
counting
class.
it.
Yeah,
Gotcha,
yeah, yeah.
okay.
Like we have 4 potential meeting days. Yeah, yeah.
Right, okay.
Yes, yes. I see your confusion. We are not meeting Monday. We are not meeting Monday. But you're gonna have a couple videos to watch. Is that one, did you get that one, PK? Yeah, look at all that green. That looks.
I'm stuck.
Okay, alright, let's see where you're stuck.
Listen, I wrote down the,
Excellent.
yeah, but I don't know how like it works.
That is a tricky one because it's just doing the
I
odd
should like
terms.
factor something out.
No, that's a good one. Let's see. Actually, oh, this one here. Yeah.
I'm not sure if I factor it to be.
Yeah.
I'll do like a 1, 2, 3.
Let's take a look. Yeah, no, I don't know. This one actually is harder than I thought it was. So let me pick it up on the board. Do you mind? I'll bring this right back. And I'm just gonna jump straight to that one there. I gotta admit, I only looked at the first 2 and thought, oh, they're all gonna be like that. They are not all like that. But, so I'm kinda curious. I'm actually very curious how the heck we're gonna do this. Thanks, PK. Just so you know, these are hard. The first one you were stuck on, that one was write it out. This one, I'm also gonna write out, but I don't know what's gonna happen. So we'll see. this is actually, we can factor this a little bit. So this is less helpful here, but you could notice that there's a 3 squared in each one of these, because there's a 3 as a factor of each one of these things, and then it gets squared. But it's more easy to see it here when I write it like this, and then I pull the 1/3 squared out front. So it's 1/3 squared times sum n equals 1. 1/3 squared. And now we see our friend, or at least kind of our friend, right? So step 1 would be
Oh,
find this. So 1 is find this, and then step 2 is multiply by 1/9. Does that make sense? I'll start thinking about this other one now, because that one looks a little more interesting, but maybe it's not. Yeah, sometimes they look so baffling when you see them at play. Oh, okay, I think I see what's going to happen here. This one's going to be kind of like this one, but it's going to require 1 extra step. Call this S. Yeah, there we go. And then I might just leave it there for a second. This is kind of like a big hint. And then you could think of this. And if you have questions about what I wrote up there, just please do not hesitate to ask. Mathematicians love to use the word, this is obvious or clearly. It's so freaking arrogant. Off-putting. How's it going? We got some green there. I'm seeing some green. Yeah, that's all right. Let me see how you're. Can I see that number 2? So let's see. Yeah. So can you show me how you thought about this one here? You see it, Jose? Awesome.
I see it.
Outstanding. Sorry, I didn't mean to whack you.
Alright, very good.
First one, I just did like subtract the first 2.
Absolutely.
And then I was like, subtract the first 2, and then I didn't, got wrong, but.
Well, what does it look like? Can you write the series out? Yeah, and some of you have squared, so you clearly have a 4th power, but the games will be the same. How'd you get 1/16? Yeah.
Just, wait, what's 2 to the 4th?
Well, 2 to the 4th is not gonna be relevant in that second series, because you don't actually have 2 to the 4th there. What's your first index? What's n's first value? 2.
Oh, okay, I see.
You see, there you go. That was probably what, honestly, that was probably what's causing your pain. But I would write it, and I'm gonna recommend one more thing. Write it out as powers, as opposed to writing 81, put 3 to the 4th.
Okay.
Does that make sense? Because you wanna see these rhythms. We're trying to find the music in it. Yeah, so how does that differ from the thing you know? What's it missing? Yeah, yeah, there think you see maybe.
Maybe.
Yeah, maybe, I was,
I'll
yeah,
talk about it.
yeah, I'm gonna let you suffer a bit there. What do you got, cans of soup in there?
Yep.
Cool.
Soup and veggies, mixed veggies.
Nice, this is how you take out the lead guy in a prison. Fill a sack.
I can do that.
Yes, sir. All right, let's see, what do we got going on
I'm
here?
working on the first one.
Okay.
Ignore that.
Oh, okay.
Yeah.
Cause you're like, I know that's wrong, and,
Yeah.
well, I mean, you got red, but, yeah, so show me how you're thinking about, show me how you're thinking about this first one. What does it look like? Let's write it out.
That's what I got so far.
Okay, cool. Where did you write out this series? Where's that on your page? 'Cause I don't see it written anywhere.
Do I need English for that?
Well, yeah, absolutely. Please write it out. So what I'm begging you is, when I give you a series, just
Oh.
write it out.
Yeah.
So it's gonna make this more obvious, I swear to you.
I see what you're putting down now.
Oh, nice.
I think, is it the subtraction
Yeah.
stuff that we've been working on?
Yes.
Okay.
Yeah.
That makes more sense.
There you go. Helps to write them out, right?
Yeah.
And keep that rhythm, show the P form.
Because I was writing it out like this and I still didn't make sense.
Exactly, no, I mean, I would have trouble thinking about that, but this makes it clearer,
Mm-hmm.
the rhythms there. Cool, now write this out, and I also wanna see that. What does that look like? Yeah, that'll be helpful. No, don't use the notation, write out, expand that. It's something plus something plus something.
Yeah,
What are
I
those?
will.
Oh, okay.
I just.
Oh, you just wanted, okay, sorry, didn't mean to
No, you're good.
harsh your buzz. Yeah, I'll come check on you in a second.
Yeah.
Just, yeah, get that guy written out, at least 4 terms.
Mhm.
I'm thinking, do you know what kind of series that is? Telescoping. Number 4 is a telescoping series. You'll have to do a partial fractions expansion. Yeah? And then I'm gonna put up kind of what you need to do, here, PK, this will help. Are you ready to have some consultation, Jose? Yeah, okay, that's what I wanted. Excellent, that looks so good. So, how does this differ from this? Let's do one more term, sorry. Let's do one more there. What's the next term?
Just 1/5 squared.
Yeah, and then what? And then what? You don't have to write it, but what's the next one after 1/5 squared?
1/6.
Yeah. What's the relationship between what you're writing here and what this is?
Both going to 0.
They are, but what about the sums? Look at the pattern. So I've got this plus this plus this plus this plus 1/5 squared plus 1/6 squared plus 1/7 squared. This kind of has that, right?
Mhm.
But it's missing what? What is the difference between those? Yes. So if I know, so this sum here is, if I take away these terms, these first 4, if I subtract those away,
Yeah.
then I get this one.
Mhm.
Does that make, are you sure?
Yeah.
Yeah, so I know what this adds up to. It's pi squared over 6. So pi squared over 6 minus that, minus that, minus that, minus that, must be that. Process that a little bit. But the trick is, I know what this adds up to. This is that minus 4 things. If I can compute those 4 things, the sum of those 4 things, I just have to subtract it from that. I'm gonna let you sit on that. Wait, do you wanna ask? I don't wanna leave you hanging.
Can you repeat that again?
Yeah, so here, may I write just a little bit, let me show you. So, let's see, so let's just call this S, because I like to have a little label, I'm gonna call that S. So we know that S equals 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus 1 over 6 squared, blah, blah, blah. We are asked to find, sometimes just organizing things a little bit, this sum. And I'm lining them up purposely. So this value here, whatever it is, differs from this value by how much? What's the difference between these 2 rows right here? Like the numeric difference.
It's just like these 4 on this one, yeah.
So if I added those 4 onto this one, I'd be back to that guy.
So are you doing subtracting?
Yes. Yeah, exactly. So find this sum out on your calculator, subtract it from the full thing, and then we'll know what this piece of it is. So this is just a piece of this thing. It's the tail end of it. So we're gonna subtract off those first ones that this one is missing. This one is missing those first 4 terms. So the sum must differ by that amount.
Because it's just additive.
Is that, yeah?
Yeah.
Okay, cool.
Yeah, I got it.
All right, awesome. And then for the next one, it's just kind of like, let's just talk real quick, just so you see how I got it.
We're doing the same thing.
Mhm.
It's just, I know the 1/3.
But you have 4, but,
For this one?
yeah, exactly, so you have 4 in, but look at the second step down, so I would just go straight down to that one, where I rewrote it as 1 over 4 squared n squared.
Yeah.
Right, yeah, and then I can pull the 1 over 4 squared out front,
So I meant.
and it's close to what I need.
What are these 2 doing the same thing as well?
No, those, yeah, they're like, yes, they're like what's up there, yes, sir,
Okay.
exactly.
So I just moved like the 1/3 square
It's like, this is
in front of it, and we have 1 over.
yours is like.
Yes, but notice that it starts, it's not exactly that. Oh wait, maybe it is, actually it is, yeah, it is exactly that. So you'll just have 1 over 4 squared times that
It's
thing,
like 4, 5, 6.
and that's what this one
So
looks
1
like.
over 4 to the 4th, 1 over 6 to the 4th.
This thing here is 1 over 4 squared times that. And so I can take that value, multiply it by 1/16, and I'll have this
So
value.
now you have to actually subtract the first 4 terms instead. Like,
Let's get some green in there first.
Okay.
I'll come back.
Yeah.
PK, how are you, friend? You good?
Almost.
Oh, you are doing, I don't know what you got there, that looks like discrete math or something there. Oh, it is, yeah. Cool. Kellen, you good, friend?
I think so.
Awesome. Kellen, why aren't you gonna take Calc 3?
And then, which one? You subtract.
You don't- I'm just kidding.
I got it, I did math on your work eventually.
Yeah?
So when you write it, okay.
Oh, that'd be great. I'd be happy to chat with you about that if you ever want to, so
Yeah.
reach out. I think you'd be really good at it. And it's pretty easy with the CS. How would you, oh, look at all that green. One last beast. Yeah. How you doing, Vincent? I haven't checked on you.
Oh, I'm getting there.
I didn't want to interrupt your cucumber snack.
Oh, you're good.
Do you got any questions or?
Maybe if I get this one wrong.
Okay, alright.
let me know.
Okay.
And we were about to find out, is that what?
Oh, yeah, I
Okay.
got it, maybe, I don't think so, but I think it's really a little weird, but, never mind, we're good.
Huzzah, okay, fantastic.
Can you see if I'm?
Yes. Wait, you know what, Yusuke, I find that I think a lot of your problems come down to not writing stuff down a lot. Just a general observation I made about you. You do, and I think that, that if you started writing more, you would make your life easier mathematically. Probably. Just a general tip. Because I think you really get it, it's just you're trying to do too much in your head. And,
So what I did was,
oh Lord.
Yeah, sure.
Okay, well, this is not what's there. What you've got here on the page is not what that is. So let's erase that whole line, because that's just, whatever. So let's actually, without trying to do anything fancy first, write this problem down.
okay.
Yes, sir, thank you. Awesome, so now, and we start at 0, yeah, perfectly. Now let's put equals and start writing out what those terms actually are, plugging in n equals 0, 1, blah, blah, blah. That looks so much better. That fourth was, you had the fourth on the first term, but not the +1 part. Originally, you were taking that fourth and putting it on that, but not that. And so you were having a +1 on everything in the bottom, and it wasn't gonna look good. It wasn't gonna be right.
How you?
Yeah, it's maybe, yeah, oh, the freshman's dream.
Yeah.
Yes.
Hate writing parentheses or something.
I think it's because you have so little practice at it.
You know what, you're probably right.
All right, now, let's put in equals, right underneath that equals, and now let's simplify it, and what is that gonna look like? And keep the fourth there, though, like something to the fourth power plus what to the fourth power?
So v 0 plus
I see your hands so not wanting to put those parentheses. You're fighting your muscle memory.
oh wait, it's a plus.
Cool, and let's put a plus, I'm just gonna get you used to writing stuff. So
Oh,
put a plus,
dot.
dot, dot, dot. There we go. We don't want our brain to get confused. Now, one more equals, and then simplify that further. Keep the fourth power, but simplify them inside the parentheses part. There we go. That looks so
Parentheses still, right?
good. No, we don't need any more parentheses. I appreciate you wondering about that, but we can let go of them at certain points. Awesome. So how does that compare to what you have?
It skips by like 1 over.
Yeah, let's write that. I like what you're doing here, so let's just write those terms where these pluses are, what should be there. So that actually should be 1 over 2 to the 4th, right? And then what's missing here? Nice. Do one more, please.
Okay.
Beautiful.
Is it even?
Yeah, so it's even. So the sum you have, this thing here, plus this thing here, is the thing you understand.
Okay.
Does that make sense?
Right.
So if I can figure out what this is, I can simply subtract it from the thing I know, and I'll have what I was given. Does that make sense? That's a lot of like to's and froms.
Can you say that one more time?
Yeah. So let's call your original sum S. So let's put okay, so say S equals right in front of it. Cool. This will help. Just write down what we need. And so we come down. So let's call this what do you wanna call it? What would you like to label it? Let's label
So
it.
why?
Okay, I like it, cool. For Yusuke? Okay,
Yeah.
fine, yeah. So let's put y equals s minus left paren this. And why would I make that noise? What's that? Why am I making that noise?
I forgot something.
Yeah. Yeah, you get it, you got it. Okay, cool. So the thing you got, the thing you're asked to find is the thing you already know, that's pi squared over 6, or pi to the 4th over 90, right there. If we can just figure out what this is, we can subtract it from that value and we'll have our true value.
Okay.
Do you see? And so now I'm gonna tell you that this one here is very much like this one here. And I'd like you to take a minute and try to figure out how. But the thing you need to find now, so the hard part was like figuring out that it's kind of like I just need to do something like this, right? And then combine them in this way. So take a minute, see if you can go from there to, yeah, okay, yeah. You doing all right?
Yeah,
Okay.
I was gonna ask,
Yeah, yeah.
I don't really know where to go from here.
Sorry, no, you're not bad. That's no good, it's all good. Okay, so I'm sorry, which one are we on? We're on,
Number
oh,
four.
yeah. So what does the original sum look like? Yeah, that's right, yeah, let's call it S.
Okay.
So we're gonna do some very similar things here. Let's call this V.
Okay.
For some reason. Okay, so V, how does V differ from S? What is it missing?
Any even number?
Yeah, so let's express that mathematically. So we could put this equals,
Okay.
and then actually, erase that a second, put plus, dot, dot, dot. Nice, equals. Okay, what does it equal? How could you express it mathematically?
Like 1 over. How do you get 1 over? Oh, to the 4th plus 1, or,
Let's not even try to get fancy with notation.
okay,
How does it relate to this quantity S? So we're gonna use S in here.
okay,
So V equals, how does S play into that right side of the equals? And the things that you know this series differs by, right? So we're missing the even terms,
yeah,
right? So let's write that mathematically. So this equals S
like plus 1,
minus
or minus,
left paren. Now put the 1 over 2 to the 4th plus 1
okay,
4 to the
Yeah,
4th.
that's-
Yep, yep.
because those are even
All
ones.
the even ones. Cool. Sweet. And then right paren. Awesome. So you know S. It's pi is 4th over 90.
Yeah,
How are you going to find that? And the answer is the same way you found this. You just got to do a little work with it on your own, a little factoring.
okay, so on the outside it would just be like, shoot. Was it,
Mm-hmm.
and then minus, whatever the answer is.
Yeah, and spend a little time trying to crack that, but it's this game right here.
Okay. Thank
Got
you.
it? You're welcome. Oh, yeah. Great. Oh, is this our class? This your? Yeah. Okay. Okay. Cool. It's a lot of red. What's going on
No,
here?
I just started.
Okay. Okay. All right. I'm back. Oh, you got it. Awesome. You're nice. Don't be jealous.
I'm just stuck.
Okay. So let's write some more. That's sometimes the answer. So let's
do a little, where can we do some scratch work, maybe up here or
Yeah,
something?
maybe.
Below, yeah, let's copy that thing down.
Can I ask a question real quick?
Yeah, absolutely.
So, down here, once you multiply each of the terms by 1/9,
Yes.
do you then multiply by 1/9 again, all over?
Can you show me what you mean on paper?
Let me just,
Okay, so this, first off, this looks awesome. This looks great, I love this.
Okay.
So let's write in equals, and then maybe, I think this is gonna answer your question. Put a 1/3 squared. Left parenthesis. What is left inside the parenthesis?
1/2 squared.
Yeah, yeah, exactly, wait, no, sorry, I just wanted to check something here. Where did we start at? Are we starting at?
Me too. I'm doing this one, the second one.
Oh, okay. Well, where did I'm a little confused how you went from this to that. Can you explain that to me?
Well, cause I asked if I
Well-
bring the one,
So that's, I was talking about this one where you
Oh.
factor things out. I'm sorry if that was
no,
confusing.
yeah, you were, and then I asked if I do the same for this one.
Oh, I thought you meant for this one. Sorry. Okay. No, you do not. For this one, write this out. What's the first term? Let's do it. So it's gonna be a little bit of,
I have that here.
okay.
It's easier.
Cool. Okay. So, didn't we do that one? That was this one.
No, we didn't. This, I mean, this one.
Oh, okay. How does this thing that you just wrote out compare to the thing you found in number one?
So what I found in the one?
So, what it looks like. So this series here that you're looking at.
Do I compare it again to?
Well, just look at the form. What is the rhythm? So you've got this written out. It's 1/5. It's 1/5 squared plus 1/6 squared. What was this one?
The same,
So what should the value be?
the same. Okay.
Is that good? So always look at those rhythms. Look at that plus, 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 plus stuff. That's where the magic lies. It's hard to think about that compact notation. It's very difficult. Does that make sense?
Yeah.
Okay, all right.
Got it.
Awesome. All right,
But
cool.
I just brought up this.
Yeah,
thing
yeah.
backward.
Let's call that, put a little like brace or something. We're gonna call that, J for Jose.
Sweet.
Okay, so now let's write J equals, and then write out what it is.
Okay.
So we can like look at the symbols and help our brain.
Alright, it's plus.
No, oh, I'm sorry, no, that's not what I meant. I mean,
Oh,
this,
oh.
just this, the series, the actual 1/2 to the fourth plus 1/4 to the fourth. Sorry.
I see.
Yeah. Cool. So now underneath that equals, put equals, and then can you, so we're gonna have, this is 1/2 times 1 in parentheses to the fourth,
Wait, 1/2 times 1 to.
parentheses around the 2 times 1. Cool, plus.
Let me check.
Yeah,
Absolutely. Too like big.
Yeah, there you go. Plus. Now what does the next one factor into? There you go. Nice. Keep going. Awesome. And then plus dot dot dot.
Oh yeah.
Do you see anything common?
Yeah.
What is it?
It's 1/2.
To the full.
Oh, 1/2.
Yeah, so let's do one more. We're gonna type equals again. You're gonna write more math in parentheses than you've written your whole life right now. So equals 1/2 to the fourth times 1 to the fourth. No parentheses.
2 to the 4th times 1 to the 4th.
Yes, sir. Do you see how I got? And yeah, write the 1 to the fourth.
Oh, like this, like
Yeah.
distributed.
Yeah.
Okay.
Do you see how I got that?
Yeah.
What's the next one?
what is common here? What do they share that doesn't change?
Two, 1 over 2 to the 4.
Yes, sir, so let's put equals. 1 over 2 to the 4th, left paren. What is left when I remove that?
It's the n to the 4th.
Well, yeah, but just not even thinking, don't get too fancy, just what's left from the page, yeah. There you go. Awesome. That's okay, I knew, I saw you go back, yeah, exactly. Okay, does that look familiar, the stuff in the parentheses?
Yeah, it's just the same function, so
Yeah.
it's pi over, or is it pi squared? No,
Yeah,
pi to the 4th.
pi to the 4th over 90, yeah. Okay, so now you know what J is. It's that number times that number, right? You know what S is,
Okay.
and you can find U squared. Does that make sense?
Yeah.
Try it, just try pulling it together.
So it would be written out this long though? Like that?
Yeah, exactly.
Interesting, okay.
Yeah.
And is this a rounded number because I did first 3 terms?
Yes,
Oh, I see. Okay.
good work, really good work. Is that, did something happen?
Yeah, it makes sense.
Okay.
It's gonna be hard after like break too because
Don't worry, I'm gonna give you stuff to do over break. I wouldn't leave you hanging like that. We're all gonna have stuff to do over break. So no, don't worry. I had that already planned out. You didn't do anything to anybody. Does anybody need more time on this assignment?
Wait, when is it?
I don't even know, probably Sunday.
Oh, that works.
That works for you? We're good, we can try it and see. And if you need more time, I'd rather have you take that time to understand. Yes, sir.
This looks right so far. This is 4.
That looks so good, Jose. Yeah. Uh-huh.
Okay.
Yeah.
Then you subtract this, from this, right?
So let's, mind if I just tweak something? So we're just missing our little buddy there, that's all. And then I'm gonna put an extra thing in here, so this is 1 over 1 squared. So what is common to all of those terms? What's common?
The 1 over 4 squared.
Yeah. So we're gonna factor that out. We're gonna actually work directly with what we got here. So I'm gonna write that, I'm gonna put a left paren, right paren. What's left inside the parentheses?
This without the 1 over 4 squared. Like always.
Yeah, so let's write it out. Nice, plus dot dot dot. Cool. Does that look familiar? The thing in the parentheses.
It's just going to 0. Is that what it is?
No, I'm looking for what is the rhythm of the things that are being added. Have you seen that anywhere else on this page? Do we see this pattern anywhere else on this page? You do, don't you? And we might even know what it is. What is it? What is the value of the thing inside there?
You want to keep the K.
There you go.
Yeah.
See?
When you get like over
Yeah.
Good work. Good work.
Oh,
It's a push. This is literally the hardest part of the class. And so don't you know, it should feel like that. Those feelings, those are natural. Those are healthy feelings that everyone's having.
Okay.
Everyone, you having some healthy feelings here, Yusuke? Looks like it. So, so how did you approach this?
I just did some, because I didn't know.
Well,
what
this
to
is,
do.
so I had written up on the board, you might have missed it. Number 4 is a telescoping series. It's, I just erased it, I think.
Oh, it was
but,
like on the.
Yeah, so just from the last part of what we did on class on Wednesday, you're gonna need to do a partial fractions. Okay. On this part. And then you can kind of see it up there, but it's certainly in the recording, like a step-by-step what you need to do. So you need to do partial fractions, and Vincent, if you're curious, just so you know.
Yeah, I'm like right.
Okay, cool, so do a partial fraction on this general term. And then write out the first partial sum, second partial sum, third partial sum, using that factorization.
Okay.
Look for what cancels, because a lot of stuff is gonna cancel.
Okay.
And you might, I highly recommend going back and just watching the end of Wednesday's class. A lot of stuff's gonna cancel, probably everything's gonna cancel but the first term and the last term. And then from there, you can kind of generalize to the nth partial sum. So that's like step 3 that is kind of erased over there. And then once you have that general formula, you take the limit. And the limit will be the least of your worries. That'll be easy.
Okay.
Because part of it's gonna go to 0.
I see.
Yeah?
Yeah.
Okay.
See,
Yes. Yeah, let me go get PK real quick. Yes, sir.
so I found the formula to be for this one, 1 over n minus 1 minus 1 over n. I don't know if that's what I'm supposed to put in here, but when I solved it with it, I ended up getting like 1 over 3, because the first one is like 1 over 3. So I wrote this one, but I don't know what I was supposed to write.
So what's S1 look like?
This one is 1 over 3 minus 1 over 4.
Cool.
This 2 is 1 over 4 minus 1 over 5, like that.
Yeah, but we're gonna organize this a little more. Let me show you so we can help our brain see the patterns. Do you mind if I can I okay. So, S1 equals 1 over, what is 1 over 3 minus 1 over 4. S2 equals 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5. This is, yeah. So, let's do one more. S3 equals 1 over 3 plus 1 over 4 plus 1 over 4 minus 1 over 5 plus, what's the next thing?
1 over 5 minus 1 over 6.
Yes, sir. Cool. So S3 is 1/3 minus 1/5. S,
The one
excuse
thing.
S2. S3 is,
Now I'm second guessing myself. I was like, I was actually thinking about that. I was like, yeah, I told him that's gonna be easy.
so, let's start up here. This is 1/3 minus 1/4. This is 1/3 minus 1/5. 1/3 minus 1/6.
Plus 3.
Yeah, exactly. So it's 1/3 minus 1 over and plus 3.
Okay.
See?
Yeah, I see.
Yeah, good work, good work. Just organize, needs a little more organization. Yes. Did it not like that?
No.
That's a weird error. What is that error? Variable n is not.
Use capitals for that one.
Oh,
Oh, right, because they gotta count, that's, okay. That's, yeah, that's jumpy. There you go. Good, thanks, Ellen. Yeah.
it's wrong.
Well, it still says, let's see, so what did we do wrong? Maybe we did something wrong. Oh, wait, so.
I should try the original formula.
I think that your sums. Oh. Cause n starts at 4, right? So it's 1/4. Okay, yeah, you know, you got it. Yeah. I don't think that's not good. Yeah, but you don't have your 1/4. so let's take a look. Let's just make sure. Let's just go through and do a quick sanity check. So, can I see your partial, so this is your partial fraction?
No, it's this one, here.
Okay, cool. So you're saying A equals one, B equals one, and
A minus one.
A is minus one, okay, gotcha. That makes more sense. Yes, so I agree with that. So we have one over n minus one over n minus one. Yes, and that is what? So it was.
Yeah.
And then n started at.
No, that's actually the other way, this negative and this positive, so.
Oh, right, okay, got it, thank you, and that makes sense, because otherwise that would be a negative number, yes, sir. And then we started at four. Okay, so it's 1/3, yeah, okay, I just wanted to check all that, alright. So this is true. This, boy, that sure is true. Do you mind if I try typing in what we had just to make sure? So it was 1/3 minus 1 over, and then what do we say, n plus 3? Let's check our formula. So let's see, so using our formula,
Well, I was also thinking about it, if this is wrong, like the second answer won't be right.
well,
Because-
so, no, that's not necessarily true. So the 1/3 is correct.
Yeah.
And this part will go to 0 no matter what, it's just the form of it. But what I'm thinking, PK, is that since n starts, because, so this was for n equals what? Here's the problem. 4, n equals 4. This was for n equals 5. It's not this.
Oh, okay, I see it, I
Alright,
see it.
so this should, I think this should just be 1 over n.
Yeah.
Let's try that.
Oh, that makes more sense.
Yeah, alright, that's tricky, very tricky.
You said for this one, it's on this.
I'm sorry, so where we at, we're on this one here? Yeah, it's this.
Right. And you said this equals this, right?
Yes.
And that's what I put in.
Well, I mean, this equals that, but that's not what we have here, we have 1/16 of that. Did you write 1/16 of that in there, like? Yeah.
Okay. And then also,
Yes.
another thing, I was working on this one,
Mm-hmm.
so I have this, right,
Yeah,
which is pretty much different, well, it's basically that, right there.
correct. Yeah, it's actually exactly that,
Yes.
yes.
So, I was thinking, I got those right there, those terms in the bottom, and
Yeah.
subtracted from, pi squared over 6.
Yes,
Is
yes,
that right?
that is correct. So let's write out a few things here, if you don't mind.
Yeah.
Yeah, 'cause, so this is equal to, let's say that this is our S, I'm still gonna, when I refer back to S, this is what I'm referring to. So it is that sum, the pi squared over 6, minus, what is the difference between, let's not think about what's on the board, let's think about it fresh. What is the difference between what I have here and what S looks like? What is this missing that S has? No, yeah, well, let's just think here.
Sorry.
It's okay. This. Very good. Beautiful. One couple more. One more, just one more. I think it'll help. Plus, dot, dot, dot. Beautiful. Very good. So now, this, let's do a little bit more work. So let's put equals. S, however you want it. You don't have to do my fancy Gothic S. Minus left paren. And let's write this sum in a different way. So it's 1 over 2 squared times 1 squared. Yeah.
1
well, don't write that, right, 1/2 squared times 1 squared. You see what I mean?
Oh,
Yeah, cause we wanna keep that hidden rhythm. If we put 1/4, we're not, like, ask Yusuke, he did that too, and it was like a miserable. And what's the next one? I don't know about that. Well, that's true, but we're looking for a rhythm that looks like this. We're trying to find this, everything has to come back to this, cause this is all we know. So this is 2 squared times 2 squared. Notice this is 2 squared times 1 squared. This will be 2 squared times 2 squared. What is that one? In the way that I'm thinking.
Why is this 2 squared?
Well, 4 is 2 times 2.
Yeah.
So if 4 squared would be 2 squared times 2 squared. You're right. You agree with that? Agree with that?
Oh, I thought you meant putting 2 squared.
Yeah, no. I thought it would help to write. Do you see what I'm saying?
Yeah.
So let's put 2 squared times 2 squared. on
Gotcha,
there.
okay.
What's that one gonna be? No? Look at the rhythm. What is the first one? What is the second one? What is the next one? Yes. Yes, but show me the next one. Yes, beautiful. Plus. Yeah, we can go. Yeah, I think we're good. So now you're starting to see the rhythm.
Okay.
What is common to all those? What is common to each of those fractions?
The 1/2 squared.
Beautiful. So let's put a line equals s minus left paren. Let's put 1/2 squared. Well, you can go ahead and put it in the parentheses. So put 1/2 squared, so we don't have too much scratching out. Starts to get hard. Right paren, put a right paren there just to kind of close that off. Yeah, nice. Now, what is left inside? Beautiful. Yes, sir. Love it. Awesome. Love, love, love. Nice. Does that look familiar?
Yep.
Yeah.
Okay.
So we know this,
Mhm.
we know this, we can find our value.
So you multiply 1/2 squared times this, and then you subtract this from.
Yeah. Yeah, exactly. Correct.
Gotcha.
Yeah?
Okay. That makes
Awesome.
sense.
Yeah, good.
Thank you.
You're welcome.
Math ain't mathin'.
This is more of my work, but I think this is probably where I was headed.
How'd you get this?
So I wrote each of these out in fractions, 1/n plus 1/4 plus 1/n.
Cool. Where's S1? What does S1 look like? So using your factorization, let's just double check that. That looks beautiful. What does K start at? 1. Okay, we gotta double check that because PK and I had a miserable time with that. So write out S1 equals. And what is that?
Gonna be
Nice. Yeah, look, you're trying to make me so happy with your parentheses. It is. Cool. So let's simplify that and then put equals, like just make it simple. It's 1/what? Yeah. Beautiful. What is S2?
Should I
let's-
write it out like this?
Let's see if we can just like,
Just simplify
yeah,
it.
go straight to that. But let's do it term by term. Yep, and then,
It is skip.
you did skip stuff, so let's slow down. S2 is this, but so let's erase that.
Erase that 1/6 plus 1/5, or plus 1/7. Yeah, oh, wow, that's nice, that's cool how that works. So it's this, because this was when, K or, we have the, so this was for K equals 1.
Oh, I have to add this.
Yeah, so write down again, 1/5 plus 1/6. And actually it should be minus 1/6, shouldn't it? Because, your partial fractions decomposition was, yeah, I think we're missing a minus, and I was putting it in, yeah, because when you add these two fractions together, you're gonna get 2K plus 9 on top. And that's not what you want, you want a 1 on top.
Okay, so,
Let's check your partial fractions. Sir, can I see your receipt before you leave the store? So this should be a minus in there, I'll just tell you.
it is,
Yes.
in here was. Wait. It would be mine? I guess
How do you do partial fractions? Let's do it. So write 1 over,
Okay.
1 over, right, yeah, right, let's do it.
That's what we do for number 4, right?
Just write this factors, okay.
Yes. Equals A over K plus 4 plus B over K plus 5. What do we do next for partial fractions?
Do we factor it out?
No,
No?
we flatten it out.
Oh, we don't want the, oh, I see, I know.
Yeah, there you go, there you go. And then, yeah. There you go. And what's on the left side? So there's an equal, let's put it over, let's keep things aligned. Put in equals there, and then what is the left side?
Just the same thing?
No.
No.
Because you already multiplied through by K plus 4 times K plus 5.
Oh, so it's just one.
There you go. Nice. Pick some nice K values.
One.
Better. That's not a very good one. That's a very painful one. You could use it. I don't think you want to suffer
Oh,
that
I
much.
see. -5.
There you go.
-4.
Yeah.
Okay. So that'd be,
So let's write K equals. Which one you want to go for first? There you go. Then what's the equation become?
I'm just.
Equals what? No, I'm gonna help you. I gotta help you. We gotta get our brains straight. Erase that equals, please, because there's not, just that one. Yep. Colon, put a colon. The left side is still 1.
Oh, I see.
Equals, there you go.
So it'd be 1 over. This is.
Yes, sir.
Okay.
So what's B?
Okay, well,
Here we go.
okay.
Let's find A.
Oh, this is
Yeah.
a partial fraction.
Yes.
It's been a while.
It has been a while.
We did this in, when we were doing integrals, huh?
Mm-hmm. And I did it on Wednesday.
You did. I didn't make the connection till now.
When I said it. There we go. Now we got a good one.
That's T.
Yes, sir. So start, give me S1, S2, S3, write them all out, don't do any work in your head, do it on the page.
This question, I
Oh, lordy, okay. So which part is, yeah, which part of the page? Okay, cool.
Because part 1 was,
Yeah.
We can make it where you
What's the, so as n goes to infinity, what's the inside of the natural log of one? What's n plus one over n going to? No,
So there's nothing I'll show you tomorrow.
when n is large, say n is a
Oh, wait,
million.
so it's like, so I was looking at it like, this one is always better than the bottom one.
But by one,
Yeah.
so what's a million and one over a
You
million?
should tell your supervisor.
Wait.
If I continue, I gotta go.
Right. Bye, guys.
Bye.
Bye,
I
alright.
have to go.
All right, cool. Keep an eye out for videos.
Okay.
And please work over the break.
We will.
You see how it's gonna be needed, right?
Thank you.
Yeah.
Okay, cool.
Thanks, Dr.
Thank you. Have a good break too. Good mathy break. Alright, so A1 or B1 equals natural log of 2 over 1. Actually, let's just look at this n plus, because that's the part that's moving. So let's just look at n plus 1 over n. What happens as n goes to infinity? So first off, how do you do a limit of a fraction? What are all the various ways we can do that?
Yeah, I was thinking like m over n, so it cancels out.
Yeah, go ahead, divide, yeah, I like that. So let's write equals lim. N goes to infinity, and then divide the top and bottom by n, what do you get?
Yeah, 1 over 1, or 2 over 1.
No, 1, so what's this, yeah, okay, then over, yes, over 1, there we go.
Yeah,
Now what happens?
it becomes 1 over
And this is
2
1 over n, this should be 1 over n here.
Oh, okay, I see.
Now you see,
Yeah,
what's the limit?
so it's 1 plus 1 over n over 1 down, this goes to 0.
There you go,
Then this becomes 1 over 1, so just 1.
yes. So what is the natural log of 1? What's the natural log graph look like?
So,
Yeah, can, yeah,
I don't know,
I don't know if we're
I-
gonna launch a rocket with that one, but,
I don't know,
yeah.
something like this, or
Yeah, where's it in, yeah, so where's 1, where's 1 on there?
1 is here.
Yeah.
So 0.
Yes. I have to get going, gentlemen, I have a